By the name of God, most merciful, most kind, peace be upon you and God's blessing. In the previous 3 videos, we have discussed the pivoting, partial pivoting, and scaled pivoting. And the last video was we talk about the complete pivoting. Due to the pivoting, the matrix A would be no longer equals to LU, but we will get a new expression that the permutation matrix multiplied by the matrix A is equal to the LU. So the title of 2.43 in the numerical analysis book by the Professor Timothy Sauer is PA equal to LU factorization. I quote, in this section we put together everything we know about Gaussian elimination into PA equal to LU. Factorization, this is a matrix formulation of elimination with partial pivoting. The PA equal to LU factorization established workhorse for solving systems of linear equation. As its name implies, the PA equal to LU factorization is simply the LU factorization of row exchange version. So, before we have solved or get the expression or do littles for either 2 by 2 or 3 by 3 by considering that the matrix A equal to LU. But due to the situation of matrices whether the pivot is 0 or very small value, the expression is becoming PA equal to LU. Due to the exchange, so we must be careful about fitting the row exchange information into the factorization. We need to keep track of the previous multiplication when a row exchange is made. We move to the second slide. This is example 214, 2.14, page 99 from Professor Timothy Sauer book. Apply Gaussian elimination with partial pivoting to solve the system 2.1. He gave us matrix A in the augmented form, A augment B, 1, 1, 3, 3 minus 4, and 2. And we can write the two equations as x1 plus x2 equals 3, and 3x1 minus 4x2 equals 2 from the augmented matrix. The exact solution is x1 equal to 2 and x2 equal to 1. To perform the partial pivoting as required, first we are going to check whether the A11 is bigger or A21. We compare the absolute value of 1 and the absolute value of 3. We find that the absolute value of 3 is bigger than the absolute value of A sub 11. So we are going to swap or to make row exchange. And the swap R1 to become R2 and R2 will become, and R1 will become R2 and R2 will become the first row in the new equation. So we have 3 minus 4 as R1 and 1 and 1 as R2. What will be M, new M sub to 1? We need this 0. So we will multiply minus 1 over 3, R1, we add to the R2, and get the new value of R2 as we know. This is the original matrix. This is after the swap. So A augmented B. After we make a swap, this is becoming 3 minus 4 and 2, and 1, 1, 3. This we call it PA, because it is the original matrix multiplied by the permutation matrix. Permutation matrix due to the swap of second row to the first row. This, the right hand side, is becoming PP. In order to proceed, we need this to become 0. We multiply by minus 1 over 3 by R1 we add to R2. All the value will be placed in the R2. R1 will be kept the same, 3 minus 4 and 2. Minus 1 over 3 by 3 and add to 1 will become 0. Minus 1 over 3 multiplied by minus 4, it will become plus 4 over 3. We add to plus 1. 4 over 3 plus 1 is 4 over 3 plus 3 over 3. We get 7 over 3. And for the final value of B, we have minus 1 over 3 by 2 minus 2 over 3. We add to 3. We get 7 over 3. We have now 7 over 3 x2 equals 7 over 3. For x2 value, we divide 7 over 3 over 7 over 3. We get x2 equals 2. We make back substitution for the value of x1. We have 3x1 minus 4, x2 equals to 2. So 3x1 equal to 2, and we will move the minus 4x2 to the right hand side. It will become plus 4x2. Since x2 equals to 1, we have 2 plus 4 multiplied by 1. We get 6. So we have x1 equal to 2 and x2 equal to 1. We refer back to the second slide where we have x1 equal to 2 and x2 equal to 1. There is no change between the exact values and the equations after partial pivoting. Now we will move to the expression of LU, how we can derive the formula. Okay. After we have shifted the second row to become the first row, so the matrix A is no longer A, it becomes PA, or the permutation matrix multiplied by A. Now we will proceed to do the elimination to get the upper matrix. In order to, this is the same procedure we have done before. We divide minus 1 over 3 multiplied by R1 plus R2 to minus 1, 3 multiplied by 3 is minus 1 plus 1 equal to 0. And minus 1 over 3 multiplied by minus 4 is plus 4 over 3 plus 3 over 3 will become 7 over 3. Thus we have get our U matrix, for which U11 equals to A11 and U12 minus 4 equal to A sub 1, 2. And this value is U sub 2, 2. This is the U matrix. As we know, we will change this sign and will become, for the L matrix, we have a diagonal 1, 1 due to Doolittle, and we change the sign of 1, 3, it will become L sub 2, 1, it will become 1, 3. So we get L and U. We will multiply the lower matrix L by the lower matrix, by the upper matrix U. We have 1, 0, 1 over 3, and 1. And for the U matrix, we have 3 minus 4, 0, 7 over 3. We have for the first 1, 1, first element 1, 1 in the PA matrix, we have 1 multiplied by 3, 0 multiplied by 0, we have 3. And 1 by minus 4 and 0 by 7 over 3, we have minus 4. Actually, this is 1, 0. There is no change between this and that. This is one third of first row added to the second row. So we expect to have 1/3 1 plus 0, we have 1. 1/3 minus over 4 plus 7 over 3, we have 1 here. We will compare this matrix and this matrix. We find them identical. This is a matrix PA, which we have obtained from swapping the second row to the first row. 3 minus 4, 1, and 1. So we come to the conclusion that the permutation matrix multiplied by A, all multiplied by X, is the permutation matrix multiplied by B. And the expression we have is that PA is LU. This will lead us to LUX equal to P multiplied by B. And this is the previous expression prior to the row extension, which is AX equal to B. We'll move to the next slide. We want to get the values of X1 and X2 to L by U multiplied by X1, X2. This is the permutation matrix. We call it B21 because we have swapped the R2 become R1. So instead of the identity matrix, normal identity matrix, we have 1, 0, 0, 1. We have moved the second row become the first as first row. So we have 0, 1, 1, 0. Again, L by U by vector X1, X2 supposed to be equal to 0, 1, 1, 0, 3, 2. The final PB value is 0 by 3 plus 1 multiplied by 2 is 2, and 1 by 3 plus 0 by 2 is 3. We can write the expression for x1 and x2 as two equations. We have 3x1 minus 4x2 equal to 2, and x1 multiplied by 1 by x1 plus 1 by x2 equals 3. In order to solve for x, we know if LUX equal to BB, we'll multiply here by L minus 1, or the inverse of matrix L, and at the end we multiply by U minus 1. L by L minus 1 will lead us to I, and U minus 1 multiplied by U, it will lead us to I. So at the end we have I by U equals, and we check the right hand side. We have multiplied by L minus 1, and this is PA, so this is P21 by B. On the left side, L minus 1 inverse of lower matrix, and U minus 1 is the inverse of the upper matrix. So in order to get the X value, we will equate it to the inverse of upper matrix multiplied by the inverse L minus 1, inverse of upper matrix by the inverse of lower matrix by permutation matrix P21, all multiplied by B. If you have L matrix as 1, 0, 1 over 3, and 1, it is easy to find the inverse matrix by swapping 1 and 1 here and 1 goes here. There is no change, and we change the sign for the two other elements. So the inverse of matrix L minus 1 equals 1, 0, minus 1 over 3, and 1, all divided by the determinant, which is 1. While for the U matrix, the elements are 3, minus 4, 0, 7 over 3. In order to get the inverse of U matrix, the determinant value is 21 over 3 plus 0. 21 over 3 is 7. Will be in the denominator. While we make swap, this element will come here, 7 over 3, and the 3 will come down, and change the sign 4 and 0. So U minus 1 elements are 7 over 3, 4, 0, and 3, all divided by 7. In the next slide, we are going to find what are the final values for x1 and x2. As we have determined that the vector x can be expressed by the multiplication of U minus 1 by L minus 1 between brackets, all multiplied by 2, B21 by B. This is the U minus 1. So column vector x can be represented by x1, x2. We have, this is the inverse of u, 7 over 3, 4, 0, and 3, all divided by 7, followed by L minus 1, which is 1, 0, minus 1 over 3, and 1. This is permutation matrix B to 1, 0, 1, 1, 0, and the B, 3, and 2. Seven over 3 by 1 plus 4 minus over 3. We have 1. 7 over 3 by 0 plus 4 by 1 equal to 4. 0 by 1 plus 3 multiplied by minus 1 over 3 will give us minus 1. 0 by 0 plus 3 by 1 will give us 3. This is B to 1, and this is again the B. x1, x2 equal 1 over 7. 1, 4 minus 1 or 3. And 0, 1, this will make swap. This 2 will come up, and the 3 will go down. Finally, we have x1, x2 equals 1 over 7 multiplied by 1 by 2 plus 4 plus multiplied by 3 is 12. 12 plus 2 is 14. And minus 1 by 2 plus 3 by 3, we have 9 minus 2 is 7. So x1 is 2, and x2 equal to 1, which is exactly match with the values of x1 and x2 prior to the swap of the rows. We come to the end of our discussion. Thanks a lot. Goodbye and take care. God bless you.